Hello again, Astro Imagers. Steve Duffy here. Another episode of PixInsight tutorial, otherwise known as yelling at software you can't understand. In today's episode, I think we're going to try to do some stacking, some image stacking, and see if we can simplify that process for you guys. So the first thing that I'm going to do is grade my images. Now, you may hear in other tutorials to do that later. I prefer to do it first for one primary reason, which is I don't like working on a lot of images, spending time processing them only to throw them away later. I also find that the calibration process sometimes messes with the images, and so I find I get a better grading result if I just grade them right at the outset. So let's begin. So what we're looking for is a process called Subframe Selector. And this used to be a script. It is now, in the latest versions, a process. So I'm going to add files first of all. Notice that this is set to measure subframes. And add files. So we'll go to here, got a shortcut here. And I'm going to go to my lights folder. Now this says that these are all Tycho, but Tycho is actually a star in the center of the field. There's 4 galaxies in this field, and I was trying to capture them all. So anyway, let's grade the blue ones first. So we select all of our blues. You notice these are 2 by 2. So all my color frames I do in 2 by 2. So we open that. In my camera combination, this subframe scale is 2.15 arc seconds per pixel with a 2 by 2 binning. And my electron gain is 1.1. It's a 16-bit camera. Site local midnight is 1700 in daylight savings time. That's pretty good. Now the directory, the output directory, I'm going to set to the approved directory. I've already set up all of these directories because I know I'm going to need them. So I select that folder. There's a keyword here called SSWait. I never changed that, but we are going to use it. Down here we have the approval screen, and you need to put some formulas in there. So I've saved my formulas off in a notepad file. So I'm going to open Notepad, and I'm going to open my formula file, which is subframe formulas. Spread this out so it's a little more readable. So this is the first one, and I'll explain it after I get it copied and pasted in here. Go back and get the second one, which is this one. Okay, so those are my formulas. So 2 things are going to happen. First thing is, well, I wish it would stop doing that. The algorithm is going to reject anything with a full width half maximum less than, or no, it's going to say it has to be less than 6 or it's going to be rejected. And the eccentricity has to be less than 0.6 or it's going to be rejected. I did not put the signal to noise ratio in here because I find that the signal to noise ratio varies widely between sessions and does not vary widely within sessions, so it's not a very useful tool for selecting subframes. So this is the automatic rejection part. Down here, I'm giving it weighting. And the weighting is computed from this formula. So it takes the full width half max of the current file minus the minimum in the list, and then divides that by the full width half max of the list and the minimum of the list. So basically we're normalizing the current value to the range of the list. Okay? And I'll come back and talk about the 15 in a minute. But this is what we call a subtractive coefficient. So the bigger the full width half maximum is, the worse the picture is. So we're subtracting that from 1 to get the weight. Very similar with eccentricity. We're normalizing the eccentricity over the range of the list, comparing that specific value of the current frame and subtracting the fraction from 1, because again it's a negative value. Over here we come to SNR weight. SNR weight, we're normalizing again, but this time this is a positive value, so the better the SNR is, the better the frame. So we're not subtracting the fraction from anything, we're just using it directly. Now, I weighted these all 15, 15, 15, 15. You can change those weights to emphasize different properties. For example, sometimes you'll get a run of images where the full width half max is pretty uniform through the whole thing, and the SNR is pretty uniform through the whole thing, and the eccentricity varies a lot. So you want to emphasize picking the ones with best eccentricity. So in that case, I would raise this maybe to 25 and drop these to 10. And you can do that for any of the parameters, any one that you want to emphasize, and we may have a chance to demonstrate that. Over here on the end, I also have just a plain 15 that's added in, and that is to make sure that no frame gets weighted 0. So the minimum weight for the worst possible frame will be 15. And I do that because you don't want to throw away frames necessarily that are kind of weak, but they still have some useful data in them. So you just want to lower their weight down. The frames you're going to throw away are determined by this formula up here. So let's run this and see what happens. So like normal PixInsight processes, click on it to run. And you can see it running in the background there. And we get a result. Okay, well, you notice there's no weight applied yet. Why not? Well, because we didn't apply the formulas. So I'm going to first apply the weighting formula, which now populates this list. Then I'm going to apply the rejection formula, which you can see the little red X's. It's rejected several frames already. So we'll have to take a closer look at that. So up here, currently they're just sorted by numerical order. That's what index means. I'm going to sort by full width half maximum. And let me pull this boundary down wherever it is. I guess I can't pull it down with that window open. Well, we'll just look at it with this window. So this is a graph of full width half max. And you can see that lots of them are pretty good, below 4. And then there's some that are high. 7. That's not too good. However, there's only 22 frames, I'm a little reluctant to reject that many. So what I think I'm going to do is see how it looks in the other categories. So scroll down this list and look for the X's, and so all of those with the high full width half max have been rejected. Well, clearly I'm going to reject those two, so that's fine. But look, the eccentricity is pretty good on all of these frames. And the SNR weight, as we see, is not too variable. It's pretty consistent throughout the thing. So the only reason that these frames are being rejected is because of the full width half max. So I think what I'm going to do, what weight did it give them? 34, 36. Let's sort by weight now and see how they look. So this one, if I accept it, is weighted pretty high. Oh, that's I want the descending order. So highest weight is 56. Lowest weight is 28. Well, 28 is low because it has eccentricity. This one is low because it has too much diameter, full width half max. This one is the same thing. So I'm tempted, actually, to go up here and say this one is pretty good eccentricity. I'm going to keep this one. So I just double click and it keeps it. Okay? And then I've got one even higher up there that I'm going to double click as well. And so that was the two lowest ones on the list. And I think I will reject those other three. Now, just for fun, I'm going to look at the graph of eccentricity, and it's pretty spread, but still not too bad. The worst one is up there at 0.54. I'm tempted to reject that one. In fact, I think I will. That's this one. So I'm going to just reject that one manually by double clicking. And I think that's, we'll look at the SNR weight, which again, some of the highest weights, well, they don't vary that much. I mean, the graph looks very radical and irregular, but the whole range is pretty small. I mean, sometimes you get SNR weights of 10, so you know, a range of 0.2 on this graph is not much. So I'm going to go with that. I'm going to say this is my list. Now, one important thing you have to do, I'm going to sort by weight again, or it is sorted by weight. Go to the top, and you have to remember to write this down, because once you do this, there's no way to go back and look at it without going through this whole process again. So this is telling me this is my best picture, number 226. I'm going to double click on it to open it. Move this out of the way and do a screen stretch and make sure that it really is my best picture. And what do you know? There's a big satellite trail in there. So I don't want to use this picture as my reference, because it will overweight that satellite trail and keep it in the picture. So I've got to move on to my second choice. and see if that's any good. So close this one and screen stretch the second one, and that one looks pretty good. The eccentricity is a little higher than I would like. Maybe I'll even check the third one to see. This one is 24. This didn't open. Number 24. Yeah, let me zoom way in on this. And that eccentricity looks pretty good. Go back to this one. Stretch it. And zoom way in. Yeah, that one's okay. I think I'm going to accept number 2. So I have to write down on a piece of paper that my best blue is number 3220. Okay? Now, I close this, find my other screen here. And I'm going to say, okay, I'm ready. So what I have to do is change this now to output subframes, and it's going to dump them into this folder, the approved folder. And it's only going to dump the ones that are approved. So these 3 red ones are going to be rejected. So here it goes. Okay, so we do that same process for the green and the blue. I'm not going to walk you through that here. I will say you have to remember when I do luminance as 1 by 1, and so these numbers change when the binning is 1 by 1, different subframe scale and different electrons per data number. So remember to change that. And you can look it up for your camera if you have that choice. Anyway, I'm going to stop there for now and finish loading these, and then I'll be back. Okay, so I'm back a little sooner than I thought. When I went to do the green frames, I noticed that I have the same problem, that there's a group in that one night that has full width half max that's pretty large. And so the seeing must have been poor during that particular time of night. Yet the rest of the characteristics are pretty good. So what I want to do is knock down the value of this in the weighting. Image number 450 has a weight of 43, but I think more significantly it's the 4th one in the list. It's listed as the 4th best image. But I don't want it to be the 4th best. I want it to be in the stack, but I want it to be knocked down in weight considerably. So I'm going to go down here and change this to 30 and apply that new expression. And now let's look at 450. So the weight appears higher, but the whole range has gone up because I've included a higher number in there, 30. More importantly, this is now 1, 2, 3, 4, 5, 6, 7th in the list. Maybe not far enough down, actually. So I'm going to hit it a little harder and say, let's give it 50 times and apply that. And now 450 is down here. I don't know what number it is, but it's roughly halfway down the list. So the ones with high full width half max are now forced pretty far down the list in their relative weighting. And I think I'm going to go with that. So we're still rejecting, though, anything with a full width half max greater than 6, and I think I'm going to change that now to be 6.5. Oops. Keep that formula intact. Run that again, and so now the only two that get rejected are the last two, the worst two for full width half max. Sort by that, which is what we want, and they have comparatively low weighting compared to the rest of the images. So that's great. I'm going to go with that, and I'm going to go back and apply that formula to the blues again to get the same effect. So I want to use the same formula on all three color data sets. Now you might wonder how I can get away with changing that number so radically. Doesn't this all need to add up to 1 or something like that, or be an even percentage? And the answer is no, it does not. PixInsight does not care what you do. When it applies this formula, it normalizes the resultant value to 1 automatically. So you can use whatever numbers you want in here to influence the result. So let's finish the green ones by outputting them, and then I will go back and finish the rest of it and return to you. So here we are back again. I've just finished running the luminance data. I have quite a few luminance frames, so I'm not as reluctant to throw the bad ones away. So in this case I've thrown away, I think, 8 frames. Something I want you to notice is that when you have images or subframes with a large full width half max, those also tend to have a low eccentricity. The reason is the star is so big that it looks rounder. So don't be too misled by eccentricity. It's the combination of eccentricity and full width half max that matters. So, just to recap, I changed this value to my correct subframe for 1:1 binning, my correct subframe scale. I changed my camera gain to the correct value for 1:1 binning. I actually went back to my formulas. Because it's 1:1 binning, I had a little bit better numbers, so I reduced these values a little bit to tighten up. That's why those got rejected. I also went back from 50 to 15 on the full width half max because I didn't have that experience of a small subgroup of frames being way different in full width half max. So there you go. I will confess that twice on both blue and red I forgot to write down which frame was the best frame, and so I had to rerun it again to figure out which was the best frame. In this case, my best frame is this one at the top, 3229. So we're done with grading the images. We're going to close this process. Well, no, I'm going to output the frames first, and then we'll close this process. And when I do close it, you don't have to close all these windows individually. I'll show you that in a moment. As soon as it finishes, there's, I think, something like 56 frames it's going through. So if I just close this one, this is the main window, and everything closes. There, we are done finally. So now the next thing we need to do is cosmetic correction. I'm going to do this a little bit out of sequence. There's two main ways to stack images in PixInsight. One is manually, one step at a time, and the other is the script called the batch preprocessing script. We're going to use that. It's simpler, if you're new to this, it's simpler to get all that to work. But in that script they ask you for your cosmetic correction settings. And so we're going to do that first. So we're going to go over here and we're going to say cosmetic correction. And here's what I do is I just say use auto detect hot sigma and cold sigma, leave it at the default values. You can adjust these, not too much. I would say down to 2.5 or maybe 2, but not below that. I'm not going to apply it to anything. I'm just going to put an icon on the desktop and close that. And I'm going to rename this. Oh, sorry. Hit that little N there and rename this cosmetic. And what we're going to do is we're going to refer to that in the batch preprocessor script. So now we open the script. There it is. And it says load your files. So I'm going to add, well, first I'm going to add bias. Okay. I'm going to go into this folder and go to my darks and biases. I'm going to pick all the ones that are biased. Okay, so there we go. And you'll notice that I mixed 1x1 bias with 2x2 bias. But because that is in the name, PixInsight can read that name and figure out, and it separates them into two groups. This is the beauty of batch preprocessor, is it recognizes the name. So you have to be careful to have named your files correctly to begin with, but if you do, this is a great shortcut. Now I'm going to add darks, and I'm going to do the same thing. I'm going to pick all of the darks, both the 1x1 and the 2x2, and they are also different lengths. And you see that, so the 1x1s are 900 seconds and the 2x2 are 600 seconds. We've got all those sitting there. Now I'm going to add flats. I'm going to find a different folder here, and here are all my flats. And same thing, because the filter name and the binning is included in the flats, it's going to separate them. So it knows that there's green flats bin 2x2, knows luminance is bin 1x1, it knows red is bin 2x2, and so on. So it's separating them out. Now I'm going to add the lights, which I will do from this folder. And as before, just add them all. Okay. And again, it separates them by binning and by color. That's great. Now, here we're going to say apply cosmetic correction. And the template icon we're going to use is the one we created down here, cosmetic. Great. This is a CCD camera, so we're not debayering or anything. In my case, I'm not going to generate drizzle data. And the reason that I'm not is because this is not undersampled. If your sampling ratio is, let's say, up around 4 arc seconds per pixel or so, then you probably want to generate drizzle data. But if you're less than 2, you're kind of wasting your time doing that. So here, you might notice I have checked calibrate only. And I don't really want to do that. What I want to do is also calibrate and register. But what I don't want to do is integrate. I want to integrate separately because you can only get one kind of integration for all these frames. So what I'm going to do is say, give you the registration parameters, which I'm not going to change that, that's fine. I'm going to give you the registration reference image, which I am going to use as my best luminance, but not the one that's in my lights folder, but the approved one. You know what? I made a mistake. I should have added. I've got to go back and do this again. So I've got to remove the lights. Because I didn't use the graded one, so the weights wouldn't count. So I'm going to remove selected files. Now this time I'm going to add the lights, but instead of the original raw lights, I'm going to add the ones that are weighted. So they are in the approved folder. And I'm going to add all of them. And just like magic, PixInsight will add them and separate them. There. And the A says yes, they are the approved ones, and once again it's separated blue, green, luminance, and red into their respective categories because of the way that I named the files. Okay. So now the registration reference image, I'm going to pick my best luminance as the registration reference. And I do that because it will upsample all of the smaller 2x2 images to match that image. So everything will be registered at the end to the same image. So I'm going to go into the approved, go over to the luminance and find 3229, which is back here. That was my best luminance. Okay, and the output directory I am going to change to the registered directory. Okay, over here you have the choice. If you already have a master flat, you can select that. In this case, or master dark for that matter, but in this case I have not integrated the darks or the biases previously. Sorry. So I'm just going to let this script do it also. But if you do this, then you only have basically one file for each color. But we're going to show you how to run this whole thing in one fell swoop. So now we're going to run the diagnostics. And it says it completed OK, which means that everything matches up. Image integration, I am not going to integrate, and I hope that I left that unchecked. So let's run it. Okay, so the script is finished and I've closed it, and you might think, well, it's all good. I'm not sure what happened. I think I failed to mention, but when you run that script with all the files the way that I did, you might as well pack a lunch. It takes a long time to run, depending. That particular run took about 45 minutes to complete. I've seen them as little as 20 minutes and as long as an hour and a half, depending how big your files are. Anyway, it's done, but the problem is we don't know what happened. We don't know if we had errors or what. So let's go over and look at the output of the script. And I'm going to go to the folder that I told it to dump everything, right? Which is the registered folder. That was the one I entered in the script as the target directory, output directory. So we'll open that, and in there we see that we have the calibrated files, both flats and lights, and you can look in there and see that there they are, and they have the C on them that says they're calibrated. We have logs, which we're going to go back and look at in a minute. We have the master file, which is where it has put the master bias, master darks, and the master flats. So I always take these off and save them because I'll use, in particular, the darks. I'll use them for several months. I usually run new flats every time, but the darks and bias I save. So that's a good thing to know. And the registered results, which are here, red, blue, green, and they all say they're marked registered. But what I've noticed is that there seems to be less files here than I expected. And if I go back in particular to green, the list seems short. Luminance, yeah, 55 items, but if I look at green, there's only 16, and I was expecting there would be at least 20. So something happened, and we don't know what. So now we're going to go back up, and we're going to look at the log. And the log is a text file, and there it is. And I have it open over here, right here. And what it is, it's the output of the console during that whole process. And it is huge. I won't run you all the way through it, but there's thousands of lines here. So the first thing that I did was I started looking for errors. Well, turns out that there are a lot of errors. There are errors that because there's no correlation between the flat and the dark, because the flat is so much shorter than the dark. There are errors because it doesn't read some of the fits keywords. Well, in fact, we'll just show you that. So we'll click in here and say find the next instance of error, and it says I can't parse the eGain fits keyword. Well, it just doesn't recognize low. That's okay, I don't care. Find next. Well, it's going to find a lot of those. But there's mean square error, different things like that. It's not finding the kind of error that I'm looking for. So I'm suspicious that some of the files didn't register. So I know that in here there's an error called ransack, where it's the star matching algorithm. Oh, get back to that. So I'm going to find the next instance of that. And it jumps way down the file, and there's one that says it's unable to find a valid set of star matches for this image, blue number 3453. I didn't know there was a blue one that failed, but sure enough, that file didn't register. So I'm writing that one down, and I'll find the next one, and there is another, and that is a green one, and another, and another, and another. So I'm going to have to go off and try to register those manually and figure out why they didn't register. Point being, you need to look at this output, because you can't see it when it's happening live, and you don't know that these errors are occurring, so you've got to go search for them. Alright, so done with this. So most of the files worked great, but we got to figure out those 4. And when I get that figured out, I'll be back to see you again. Okay, so what I did, I went back to star alignment. I picked the same reference image that I picked originally, and I added those 5 files that failed to register before. And the only thing that I changed was, instead of projective transformation, I switched to thin plate splines. They all registered perfectly and dropped them into their respective folders. All worked fine. I have no idea why it failed in the script. But anyway, we're good to go now. Alright, so the next step in this process is to do local normalization on all of our registered files. So we find that process. So we'll do the blues first. So we'll pick our best file from the blues, and we're going to the registered ones, and we're going to pick 3220 because that was our best blue. I'm going to leave everything else the same, no changes. I'm going to go back, pick all of the files, including the reference file, and load them in. Now here I cannot normalize green and red with blue. I've got to treat them individually. So the output file, I'm going to go back to blue, the place we just came from. You got to watch those folder names carefully. It's very easy to get back in the wrong folder. This process runs quickly. It generates some kind of hidden files, you might say. And I'm going to do it here for the blue so that you see how it's done. But then I'm going to go off and do the others so you don't have to watch me do it. So now I've finished generating all the local normalization data for red, green, blue, and luminance. And I've stored all the normalization files in the same folder with their registered images, or their registered subframes. So now from here we're ready to go on and do image integration. I'm going to open that process, and already got blue files there. So what I need to do is add the local normalization files, which are in the blue directory. They're kind of hidden files. You see this XNML? That's a normalization file. It's a separate file from the actual image file. You load them up and you get a check mark and a normalization notation, and if any of them are missing, it will flag that for you. Now we want to set the reference at the top. Our best blue was what? 3220, and it's already at the top, so we're going to set that as a reference. Combination, we're going to do average. Normalization, we're going to pick now local normalization. For weights, we've got fits keyword, and this is the SS weight keyword that we did when we were measuring the subframe weighting algorithm. We're not going to generate drizzle data here. You can, but in my case I am not going to. Normalization here, we're going to do local normalization again. Because I have 19 or 20 files, I'm going to use Windsorized Sigma clipping for the rejection algorithm. Leave everything else pretty much at default. And we'll run this one and we'll get a blue master. And it's integrating. That error is it can't read the E-gain word. like we saw in the log file before. It just doesn't recognize the word low. It's looking for a number. Not anything to worry about. Okay, so now we've got our rejection. So this is our high rejection. And move this. Actually, I'll shrink it down. We'll stretch that. And you see it rejected the satellite path. And it rejected some of those fat stars that we remember we were talking about, the high full width half max. So it rejected some of that stuff for us. Plus a lot of background noise, cosmic ray hits and things. So that's good. The low is usually not very interesting. A few hot pixels, things, but not too interesting. So let's see what we got for our blue image. We'll do the auto stretch here. And that looks pretty clean. I like it. So I'm going to change the name on it and call it the blue stack. And leave it. Good. Now we'll go back and we'll clear this, and we'll do the same thing for green and red. So there's loaded all the files. Our best green was 3221. So we'll find that one right at the top again. Set the reference. Add local normalization files from the same folder. Make sure you get the green ones. Okay. All of this stuff is going to be the same because these are all the color frames. So we'll just leave that. I'm going to run this, and I will be back to see you again when I am ready to do the luminance. Okay, so we're back again. I've integrated, you watch me do blue, I've done green, red, and now luminance. The color frames are all done exactly the same way. The luminance is slightly different because I have so many frames. I change the pixel rejection from Windsorized to linear fit clipping, which gives a little bit better result. But that's the only real change that I made. You can see here that I've renamed them all. Just as an illustration, we'll take a close look at a couple of these. So this is the red versus the luminance. And at this scale, they look kind of similar. But if we go to maximum zoom, and we'll find this galaxy up in the corner. Here we are. Get that centered up. Now here's a nice little trick, which is you can take that tab and drop it right on that tab, and it will center the other one exactly the same way. Now, you see the difference. This is what doing a lot of 1x1 luminance frames gets you. It's much cleaner than the red frame. Now, the joy of using luminance and binned color frames is that when you put this luminance behind these color frames, all of that noise will disappear, and the detail that's available in the luminance frame is what will shine through. And the color contributes only color, not really any noise. So it's a great thing. So there we are. We're done with the stacking process. You've got all three or all four masters. It's time to move on to some real image processing. Thanks for joining.